guys, in today's video we are going to focus on how we can solve for x if the question involves exponents, right? So now before we can dive into how we can solve the expression, we first need to revise the exponential laws. Now these are your exponential laws. The first one says that if you're multiplying bases that are the same, you add the exponents. The second one is if you're dividing the bases that are the same, you subtract the exponents. The next one is if you have a base inside the bracket raised to a power, the exponent outside your bracket will multiply the power inside your bracket. So now this would mean that you have x times y, which is equal to axy. The next one is if you have a base raised to an exponent of 0, it's equivalent to 1. The next one is if you have a base raised to a negative exponent, it's equivalent to 1 over a. Now, if you have bases that are multiplying each other inside a bracket, right, their powers will multiply the exponent outside your bracket. So now this one is basically the same as this one. The only difference is on this one we have two bases instead of one. So now we have an imaginary one on each. So now this means that this is our power and we're multiplying with the exponent. So that's why we have ax and bx. Now the last one is if you have a raised to an exponent of a fraction, right? So this basically is a x over y, because the way that it's written, it's like it's a times x over y. So it's basically base a raised to an exponent of x over y. So you have a fraction. So if you are trying to convert that into its simplest form, we can convert it to a square root, right? So basically this will be the value of your square root and this will be your exponent of the base. So that's why on this one we can say that it's a raised to an exponent raised to the power of x inside the bracket multiplied by 1 over y. So if you multiply this, it will take you back to our original question. Now this becomes the number of your square root, and this becomes your exponent of the base, right? So now let's say for an example you had a 4 over 3. This would be a 4 1 over 3. So this becomes the value of your square root, and this would be equal to 3 square root of a4. So this is very important. You need to know how to move around with your square root, and if you have a base that's raised to an exponent of a fraction, how you can simplify and solve that easily, right? So now from here, another thing, if you just have a square root, right, if you just have a half, this is equivalent to a square root of a. So we have an exponent of 1. So now we do not have to write the 2. You can just write the exponent alone. So the only time you can write the value outside if it's 3, 4, 5 going forward. But if it's 2, just write the square root alone. Now from here, how do we solve this? So now the next thing that you need to understand is on your left hand side, you need to only have a base and your exponent. We do not need a variable. So basically this is the form. It's 2a. Let's just call this x. So now this is what we call a variable, and this is what we call a base, and this is what we call an exponent, right? So you must make sure that on this side, on this left side, you do not have this variable. So how do we get rid of this? You are going to divide both sides by 3. This will cancel out. So now you have x 3 over 2, it's equal to 24. Now from here, it's equal to 8. So 24 divided by 3, it's 8. Now the next thing that you're going to do is if you can convert your whole number to its simplest prime factor, then that's exactly what you need to do. So x is 3 over 2, it's equal to 2 cubed. So if we're converting our 8 to its simplest prime factor, it's equivalent to 2 cubed. Now the next thing is, as you can see here, we have a fraction. How do we remove that? So what you're going to do is you're going to multiply your exponents on both the left and the right hand side by the inverse of the original fraction. So now this means that if you have 3 over 2, it would be multiplied by 2 over 3. This is the inverse of the original fraction on both sides, times 2 over 3. So these will cancel out. Now you have x, it's equal to, these will cancel, 2 squared, which is equal to 4. That's basically how you can solve it. Now let's look at another question. Let's say that we have 4x minus 2, it's equal to 9 log 327. Now from here, you can see that on the left hand side, we have a base and an exponent, so it's perfectly fine. But on the right hand side, we can see that we have a whole number that can be converted to its simplest prime factor form. So now this means that we have 4x minus 2 is equal to, now we need to convert this. So it's basically 3 squared log 327. Now remember, if you have a power, if you have a base raised to a power inside your bracket, that power multiplies your exponent outside the bracket. So now this would mean that we have 4x minus 2, it's equal to 2 inside your bracket log 327. Right, so now from here, you can see that both sides we have the same bases. So if the bases are the same, you can equate the exponents. So now from here, you have 4x minus 2, it's equal to 2 log 327. So now you're going to divide both sides by 2. So you have 2x minus 1, it's equal to log 27 base 3. So 4 divided by 2 is 2, and negative 2 divided by 2 is negative 1. So now from here, what can we do? We can't just use the exponential laws to simplify this further, can we? No, we can't. So here's another thing that I need you to understand. If you cannot simplify the expression further by using the exponential laws, you need to convert your expression from a log, from an exponential to a log, or from an exponential to a log. So now let's say that you have log a b, right? It's equal to x. Now how do we convert this to as an exponential form? So the base will always remain the base. It does not matter if you're just converting from expo to log or from log to expo. The base remains the base. That's what you need to always remember. Sorry about that, I dropped my pen. So now from here, so you have ax, it's equal to b. You see our base remains the base, right? Now this becomes an exponent. So now let's say that we're converting from an exponential to a log. Let's say that we have 5x is equal to 1. So now if we try to convert this, our base will remain the base. This becomes our log value, and this becomes the equated term. So now this would mean that you have log 1 base 5 is equal to x. You see the base remains the base, it does not change, and then this becomes our log value if you're converting from an expo to a log. Now let's come back here, right? So now this is our base, this is our exponent, right? Since we're converting from an exponential, from a log to an exponential, right? So now this is 2x minus 1 is equal to 27. Now we need to convert the 27 to its simplest prime factor. So now it's 2x minus 1 is equal to 3 cubed. The bases are the same in both sides, so therefore we can equate the exponents. So now that's 2x minus 1, it's equal to 3. 2x is equal to 3 plus 1. Then 2x is equal to 4. Divide both sides by 2, and x is equal to 2. That's basically how you can solve this particular expression. You understand? Now let's look at another example that we can do. Right now, let's say that we have 4x squared minus 1, it's equal to 1. Now there are two ways that you can solve this, but then if we can look at this, right, we can convert from an exponential to a log form, right? How can we do that? So now This is our base, this is our equated term, so we can convert this. So we can say it's log of 1 base 3 is equal to 4x squared minus 2. Now if you look closely at this, we know that through our log laws, if we have a log of 1, it does not matter what the base is, it's always going to be equivalent to 0. So now this means that we have 0 is equal to 4x squared minus 2, right? Now another way that you can do this is you have 4x squared minus 1 is equal to 1. So you can convert this to a base that is the same as this by using this law that says that if you raise a base to a power of 0, it's equivalent to 1. So now this means that we can say that it's 4x squared minus 1, it's equal to 3 exponent 0. This is basically the same as this. So you see, either way, it's the same. So since both sides have the same base, therefore we can equate the exponents. So that's 4x squared minus 1 is equal to 0. And then 4x squared minus 1, it's equal to, no, it's 4x squared. We take this negative 1 to the right hand side, therefore the sign changes and becomes 1. So 4x squared is equal to 1. Divide both sides by 4. Now you have x squared is equal to 1 over 4, right? So now from here, how do we remove this 2? So you're going to multiply both of your exponents by the inverse of the original. So now this means that you're multiplying by 1 over 2, which is 1 over 2. So these will cancel out. Now you're left with x, it's equal to 1 over 4, 1 over 2. So you can write this as a square root and say it's equal to plus or minus the square root of 1 over 4. Then you're done. You understand? So this is basically how we can solve, right? So now on this one, I'm just showing you how we can write the square root, but this is not the final answer yet. You can punch this. Either way, it's just going to give you the answer. So let's say that you have 1 over 4 half, right? So we need to convert this into a simplest prime factor. So now we know that it's 1 over 2 squared, 1 over 2. So that's basically going to be 2 negative 2, 1 over 2. If you multiply this, they are going to cancel out. So now you have 2 or negative 1, which is equivalent to 1 over 2. So if you would just punch this, it will still give you the answer. So it's 1 over 2 or negative 1 over 2 if we are involving this, because it says plus or minus. You understand? So that's basically how we can solve for x if we have exponents. Just understand the exponential laws, understand how you can convert from an exponential form to a log form, or from a log to an exponential form. If you cannot solve the expression by just relying on the log laws, then it means that you must convert. For an example, if you just have 3x, it's equal to 5. There's no way that you can convert this by using exponential laws. This means that you are obligated to use log. So you need to convert this from an exponential form to a log form. So this would mean that you have log. Remember, the base remains the base, but then our equated term becomes the log term, right? The log value. So now it means it's log of 5 base 3 is equal to x. The base does not change. The base will always be there. Whether you're converting from a log to an exponential, or from an exponential to a log, the base will never ever change. Now this is how we can solve for x if we're involving exponents. Just follow the steps, understand the laws, and you'll do perfectly fine. Thank you for watching the video. Please remember to like and subscribe, and if you have any question, just hit the comment section and let me know. I will get back to you. Thanks for watching.